Okay, so welcome back to the second part of the asynchronous discussion, and this will be about the ionization constant of conjugate acid-base pairs. Okay, so suppose you have an acid which is Ha. You know that the acid can separate into ions, no? Pwede siya maghiwalay into H plus and then A minus. But what actually happens is that the conjugate base of an acid, no, yung conjugate base niya, it can further interact with water. Okay? So if it interacts with water, you produce your OH and your HA. Okay? So ito, acid to, so that's why Ka yung kanyang expression. Okay? And ito, you know that this is a conjugate base, so this is a base reaction. Okay? So this is characterized by the Kb. So ngayon, ano mangyayari? So if we combine the reactions of your acid and your conjugate base, uh, what will happen is that it will just show you the ionization of water. Kasi magka-cancel out yung A minus and then yung HA. So literally, ang maiiwan na lang is the ionization of water. And we know that if we combine two equations, we just multiply our uh, constants. Okay, so that's Ka times Kb, giving us the final equilibrium constant, which is the equilibrium constant of water. Okay, so ibig sabihin yan, if given yung Ka and you're looking for the Kb, then you can use this equation. So let me demonstrate it to you. So suppose in acetic acid, okay, in acetic acid, the Ka is 1.8 times 10 raised to negative 5. Ngayon, hanapin mo yung Kb. Paano? Okay. So, you use this equation. Kapag given yung Ka, pwede mo mahanap yung Kb. And vice versa. Kapag given yung Kb, hanapin mo yung Ka, pwede. Because their product is just the Kw. Okay, so let's answer this one. Okay, so if the acetic acid Ka is 1.8 times 10 raised to negative 5, then what is its Kb? Okay, so for the Kb, basically that's okay, so from this equation we just get Kb equals Kw over Ka. So Kw, do not forget, it's 1 times 10 raised to negative 14 divided by the Ka. So 1.8 times 10 raised to negative 5. So ganun, yun yung value ng Kb mo. Which is, I don't know, let's press it in the calculator. Okay, 10 raised to negative 14 divided by 1.8 times 10 raised to negative 5. So ito pala yung value ng Kb. So 5.56 times 10 raised to negative 10. Okay? So ganun pala. So kapag given yung Ka, hinahanap yung Kb, pwede. Because the product of Ka and Kb is just the ion product of water. Okay, which is 1 times 10 raised to negative 14. So let's continue with diprotic and triprotic acid, although this will not be given more focus in Anachem. What you just need to know is that for diprotic and triprotic acid, they can dissociate into many hydronium ions. Okay, so they can donate more than one hydronium ions. Also, the process is stepwise. Okay, so ibig sabihin, pag nag-ionize siya, the two hydronium ions, let's say for diprotic acid, yung dalawang hydronium ion na yan, hindi siya lahat nababaklas in an instant. So, slow yan. So, yung isang H muna, then followed by the other. Okay? And that stepwise dissociation of proton has their corresponding equilibrium constants as well. Okay? So suppose we have a carbonic acid here. So it is a diprotic acid because you have two hydronium ions that can be given off. So in first dissociation niya shows that you form your hydronium ion and your bicarbonate. And yung bicarbonate, its hydrogen is still somehow acidic, so you can further dissociate it into carbonate and hydronium ion again. So, isa-isa yung pagbaklas ng H, ha? Baka kasi isipin nyo, lahat sila nababaklas. Okay? And as you can see here, so in this table, we have the different K values for different acids that are diprotic and polyprotic. For example, for sulfuric acid, the first dissociation is very large yung Ka niya. So what does that mean? Ano yan? Pwede siya gamitan ng stoichiometry. But in the second dissociation of your bisulfate ion, medyo may Ka na siya. For oxalic acid is also another diprotic acid. Kapag matanggal itong H na to, so ito yung kanyang equilibrium constant. If you want to remove this, that's their equilibrium constant. Okay? So for phosphoric acid, siya lang naman ata yung triprotic acid na alam ko. So 3 steps yung kanyang dissociation kasi nga triprotic acid siya. So, 3 yung H doon eh. So 3 steps yung mangyayari sa kanya. First dissociation, ito yung kanyang Ka. Second, ito naman. And then the third, ayun naman. Okay. You don't need to remember all this, ha? Isipin nyo kailangan kabisado rin. Not really. Okay. Now, let's continue with our discussion with buffers. Siguro you're familiar with buffer, no? Lalo na ngayong COVID pandemic, and let's say you have your antigen test kit. Diba sabi doon, you have to submerge your swab sample into a buffer. Okay. So what's a buffer in chemistry? A buffer is actually a substance that is not subject to changes in pH, even though you add acid or base. Okay? So pag nilagyan mo siya ng acid and base, di agad nagbabago yung kanyang pH. Okay? And actually, buffers are very important in life. Very important yan. Because, for example, our blood has a natural buffer of pH around 7.45. So, ganun. Yun yung normal pH range natin. 7.45 to 7.35. So, within lang doon, kasi buffer system yung meron sa ating body. Okay? Kasi kung walang buffer, siguro uminom ka lang ng suka. Magbabago agad yung pH ng body mo. Okay? Pero, buti na lang may buffer. And not only that, sa pag ginagamit yung buffer in our respiration. Later, I'll tell you more about it. But again, just to give you more context, our buffer is a solution that resists huge changes in the pH. So, hindi siya agad-agad nagbabago ng pH. Saan ba gawa ang isang buffer? Our buffers can be made of a strong electrolyte and a weak acid. So, may weak acid ka and yung kanyang conjugate base. O, pwede rin naman weak base and then yung conjugate acid niya. Okay? So, ibig sabihin, in a buffer to be effective, kailangan may conjugate acid-base pair ka. Okay? So, let's consider the mixture of, let's say, sodium acetate and your acetic acid. So, your sodium acetate is an ionic compound. Okay? So, it forms sodium ion and acetate anion. For your acetic acid, it is a weak acid, so it partially dissociates to H plus and acetate ion. Okay? So, yeah. If we write the Ka for the acid equation, okay, so gawa natin siya ng Ka, it will look like this. So, H plus A minus divided by HA, right? What I'm going to do next is that I will transpose this, okay? So, I will solve for the value of H plus lang, okay? So, meaning I'll transpose this term and that term. So, giving me H plus equals Ka times the concentration of acid divided by the concentration of the conjugate base. And now, what I'm going to do next is I will apply negative logarithm on both sides. Okay? So, apply ako ng negative log on both sides. Okay, what will happen? So this will be negative log of H plus. And ito, pwede sila maghiwalay, right? Diba I mentioned last time in our discussion na if you have, let's say, this thing, sorry, ito lang, if you have logarithm here, it becomes log A plus log B, right? Pero kung ito ay fraction, pwede rin naman sila maghiwalay. Okay? So, ganun lang nangyari dito. Our A being the KA. So, humiwala yung KA, and then yung quotient na HA, A minus, magkasama sila. Okay? Now, what's negative log of H? That is your pH. What's the negative log of Ka? We call that the pKa. And then the negative log of the ratio of the acid and the conjugate base. We call this the Henderson-Hasselbalch equation. And this equation governs the pH of a buffer solution. So siya yung nagdidikta kung ano yung pH niya. Okay? So this is the pH version of the Henderson-Hasselbalch equation. For the base form, ito yung kanyang itsura. So that's POH equals PKB minus log of your okay. Okay, so that is the version of Henderson-Hasselbalch equation, okay, for a base. Okay, so ganun lang. So again, saan ginagamit to? Ito ay ginagamit for determining the pH of your buffer systems. No? So, dyan natin malalaman kung ano ang kanyang pH. Sorry, I think may nabaliktad ako. Okay, so sorry, baliktad pala ako. Yung conjugate acid, dito pala yun sa baba. Okay? I forgot to type it kasi. Okay, so yung base sa taas, conjugate acid sa baba. Okay? So that's our Henderson-Hasselbalch equation. So you need to remember these two equations because they will be used in buffer systems. Okay, again, let's recall the very definition of a buffer system. Again, buffers are solutions that resist pH changes, okay? When you add small amounts of either acid or base. And it is composed of a weak acid or weak base and their salt form, which provides the conjugate acid and the conjugate base, respectively. Okay? So, this is a graph showing the buffer system. Okay? So, let's say you just add your acid into the water. When you add acid into water, the pH suddenly drops very quickly. But if you have a buffer system, tignan mo, the pH is still steady. Ganun ka-important yung buffer. Kaya nga in our body, kailangan may ganyan tayo. So now, let's take a look at this problem. Which of the following are buffer system? So, when you have a buffer system, make sure that they are conjugate acid-base pairs. Meaning, na yung difference nila ay hydrogen atom lang. Pag yung isa sobrang hydrogen, yung isa walang hydrogen, then probably that's a buffer system. So let's take a look. So, letter A. Is it a buffer system? Actually, yes. So yes, this is a buffer system. Because the only difference is that yung HF, may isa siyang H, and then yung KF, nawala yung H niya. Kapag isang H lang yung nawala, then that's a buffer system. How about letter B? Is this a buffer system? The answer is yes. It is a buffer system. Kasi ano yung nawala? Isang H lang. And the next one, we have sodium carbonate. Is this a buffer system? It is also a buffer system. No? Kasi, tignan mo, may isang H dito, nawala. Okay? So, only one H lang yung nawala. Yung mga metal, you don't need to care about them. Yung mga K, yung Na, wag nyo na lang sila pansinin. Just look at your anion and the hydrogens, no? Kung siya ay nadagdagan or nabawasan, then yeah, it is a buffer system. Okay? Let's try some buffer calculations. Okay? Madali lang to. What is the pH of a solution containing 0.3 molar of formic acid and 0.52 molar of potassium formate? Okay? So this is the formic acid. This is the potassium formate. As you can see, they are buffer. Bakit? Ang pinagkaiba lang nila is this one has hydrogen here and that was replaced by a metal. So, ganun kasi. May acid ka then mapapalitan ka ng metal. Okay? So, this is a buffer system. And again, how do we determine the pH of a buffer system? We use the Henderson, Hasselbalch equation. So, since pH ang hinahanap, then we use the pH equals pKa minus logarithm of the concentration of your conjugate base divided by the acid. Let me verify if tama yung aking copy. Sorry, baliktad pala. So, HA over A minus. By the way, let me clarify about this. Ito yung version na nasa isip ko. Let me clarify. Iba-iba kasi yung makikita nyo sa Google. Okay? May makikita kayo sa Google wherein this thing is positive and sometimes negative siya. Tapos mapapansin nyo that the fraction becomes flipped. Okay? It has something to do with the logarithm. Okay? So, may kinalaman yung logarithm. If you reciprocate the fraction, the sign of the logarithm also changes. Okay? So, ibig sabihin, another version of this equation is this one. Let me just clarify this to everyone kasi iba-iba yung Henderson-Hasselbalch per content. Okay, so that's pH equals pKa plus log, okay, of the conjugate base over acid. Ito yung nasa isip ko parate. Okay, so mapansin mo that when you flip the fraction, the sign of the logarithm also changes. Okay, so they are not different equation. It just so happened that the fraction inside the logarithm was flipped. So, ganun lang. Same with the POH, no? Kasi baka may mga makita kayo na isipin nyo, ay, mali ako ng bigay. Ano lang. It has something to do with the properties of logarithm. Okay? Okay, so these are the four forms of Henderson-Hasselbalch equation. They are all the same. Okay? Ang reason lang ba't nagkaiba ng sign is that it is just the property of logarithm. No? Algebra will answer that for you. Okay. So nevertheless, I'll use this one. So pH equals pKa plus logarithm of the conjugate base over the acid. So this one is actually molar concentration. Molar concentration yan. So madali na lang. No? So given na yung molarity ng formic acid, which is IHA, and my conjugate base. No? So madali na lang. Ipa-plug in ko na lang ito, pati ito. But the question is, what is the pKa? Kung hindi kabisado, okay lang. I don't also know. Ang gagawin niya, we just look at the KSP table that is also provided in this PowerPoint. Okay? So, ito ba yun? Okay, so ito, formic acid. So, this is the ionization constant of our formic acid. So, for formic acid, that's 1.7 times 10 raised to negative 4. 1.7 times 10 raised to negative 4. Okay? Nalagay ko dito. You don't need an ice table, ha? So, sorry. No need na yan. So, that's the Ka. Pero ang hanap is pKa. Remember, whenever you see letter P, it just means that you get the negative log of your Ka. Ganun lang. You just get the negative log of your Ka. So pH is equals to the negative log of your Ka, which is 1.7 times 10 raised to negative 4, plus the logarithm of the concentration of the conjugate base, and the acid, no? Okay, so ganun lang. Very simple lang. So just divide the concentration of the conjugate base in yung salt form and the acid. Okay. Pindutin natin sa calc. Okay. So negative logarithm 1.7 times 10 raised to negative 4 plus logarithm of 0.52 divided by 0.30. Okay, so the pH is 4.01. Okay, so ganun lang kasimple. Next one. So this problem is quite tricky. Medyo tricky siya. Pero I think onti lang yung ganito sa quiz. No? So you don't really have to panic that much. Okay? Pero medyo tricky siya. This will give you an idea on how we will deal with calculations in the next semester. Next semester. Pagdating ng finals period. Okay. So after the midterm, medyo ganito na yung mga problems na makikita niya. Okay? So let's answer this topic. Okay. So calculate the pH of the 0.3 molar ammonia slash 0.36 molar ammonium chloride buffer system. What is the pH after the addition of 20 ml of 0.05 molar sodium hydroxide to 80 ml of the buffer solution? Okay. So, ano muna gagawin mo? You answer the first sentence muna. Okay? So, the first sentence asks us about the pH of the 0.3 molar of ammonia slash 0.36 molar of ammonium buffer system. Question is, are they a buffer system? Yes. Okay, kasi sinabi na, no? Pero hindi, no? Just look at the formula, no? So dito you have 3 hydrogens, doon you have 4 hydrogens. So they are indeed buffer system. Okay, so let's answer the part 1 muna. Okay. Okay, so calculate the pH. Pero remember, ammonia is a base, right? Ang base yung ammonia. So, hindi mo agad makukuha yung pH. You get the POH muna. Okay? So, kapag base yan, POH muna gagamitin mo. Okay? And the Henderson-Hasselbalch equation for that is ito. Okay? Yung base form. Ito yung gagamitin ko. Kasi dito ako sanay. Okay? So, I'll use this one. Okay? So again, this is a base. So, gamitin mo muna yung Henderson-Hasselbalch for a base. And then what's next? Given yung mga concentration, right? So, you have 0.36 molar of the conjugate acid. You have 0.3 molar of the base. Plug in mo na lang yan dun. But the pKb, I don't know that. So, let's look again in this PowerPoint. Okay, so in this PowerPoint, I have here the ammonia. Okay, in slide number 34. So the Kb for ammonia, kasi ammonia, ayun. So the Kb for ammonia is 1.8 times 10 raised to negative 5. Okay, so 1.8 times 10 raised to negative 5 ang Kb. Okay, so lagay natin. Okay, sorry for that. So dito ka na lang lagay. Sa Kb, 1.8 times 10 raised to negative 5. So to get the pKb, so that's just simply a negative logarithm of your Kb, right? Ayan. So that's negative log of 1.8 times 10 raised to negative 5 plus logarithm of the conjugate base, okay? Conjugate acid, so which is 0.36, and your base, so 0.30. So the POH now is, pindot sa calcu. So that's negative logarithm of 1.8 times 10 raised to negative 5 plus the logarithm of 0.36 divided by 0.30. The answer is 4.82. POH yan. Pero ang hinahanap ay pH. So how will you get the pH? Just 14 minus POH. Oopsie. So 14 minus the POH. So the answer is 9.18. Okay, so that's the pH of our ammonia-ammonium buffer system. And now let's answer the second problem. And the second problem is kind of tricky. Okay, lalagay ko dito part 2, tricky. Okay, so wala masyado nito in the quiz, but you have to prepare for this because this will be repeated often in chapter 5, which will be done after the midterm period. So this is kind of tricky. Okay, question is, what is the pH after the addition of 20 ml of 0.05 molar sodium hydroxide to 80 ml of the buffer solution? Okay, sabi dyan, you have a buffer solution, tas dinagdagan mo daw siya ng 20 ml ng sodium hydroxide. So, ibig sabihin, pag dinagdagan mo yun ng liquid, the volume will increase. And what happens when we increase in volume? We what? We become diluted, right? Okay, so just like in making iced tea. When you add water into your iced tea, it becomes diluted, right? So, ganun yung nangyayari sa problem na to. When you add 20 ml of sodium hydroxide to your 80 ml buffer system, the solution becomes diluted. Ibig sabihin, originally you have 0.3 molar. Ngayon, hindi na siya 0.3. Same as this one. Originally, it was 0.36, but after adding 20 ml, nag-increase yung volume ng solution, so siya ay na-dilute. Okay. So, our first task is to actually get the diluted concentrations, no? So, ganun. Kasi nag-add tayo ng liquid, so nadagdagan yung volume, na-dilute. So, let's get first the diluted concentration of our original buffer contents. Okay. Diluted concentration of NH3 and NH4. Now, kunin muna natin diluted concentration. And what equation will we use? Okay, so the C1V1 equals C2V2. What's our V1? Ayun yung sinabi na 80 ml. Yun yung volume daw ng buffer eh. So 80 ml. What's V2? V2 is the final volume. So what's the final volume kaya? It is 20 ml plus 80 ml. It's kasi pinaghalo mo yung dalawa eh. So 80 plus 20. So 100 ml. Okay? So again, your V1 is 80 ml and the V2 is 100 ml. Okay, so let's do that. For the concentration of ammonia, so to get the final concentration C2, that will be C1 V1 over V2. So the concentration of ammonia is equal to its original concentration, which is 0.30 molar, times the volume initial, let's say that's 80 ml, divided by the total volume, which is 100. Bakit ito naging 100? Kasi you added 20 ml of the solution into your 80 ml solution. So 80 plus 20, 100. Okay, so yan. Let's calculate the concentration. So that will be 0.30 times 80 divided by 100. The new concentration is 0.24. Na-dilute talaga siya, no? And then for the concentration of ammonium chloride, we'll do the same. Na-dilute din siya. Okay, so na-dilute din siya. You have 0.36 molar times 80 ml as well, and then 100 ml. Okay, so 0.36 times 80 divided by 100. So that will be 0.288. Okay, so that's the diluted concentration of ammonia and ammonium ion. So are they the only one that is diluted? Sila lang ba yung diluted? Hindi lang. No? Also, sodium hydroxide will get diluted. Remember, its original concentration is 0.05 molar. Pero when you add it in the solution of a buffer, madidilute din siya. So, kailangan gawin natin yung dilution process. Okay? So, ganun din. So, not only for ammonia, not only for ammonium chloride, but also with sodium hydroxide. Okay? So, gagawin din natin siya kay sodium hydroxide. Okay? So, diluted concentration of sodium hydroxide. Okay? So, ganun din. C1. Okay, the initial concentration of sodium hydroxide is this one, 0.050. The initial volume of sodium hydroxide is not 80. It's 20. Okay? So 20 ml yun. Okay? So it's not 80, it's 20 ml. And then the final volume is still 100. Okay? So yung 80 ml, yun yung ammonia and ammonium chloride. But the 20 ml is the sodium hydroxide. The final volume will always be the same. Okay? So same lang yung final volume talaga. Okay? Answer. So that will be 0.05 times 20 divided by 100. 0.01. Okay, tama ba? Okay, tama. Dalawang isip pa eh. Okay? So, lahat sila na-dilute. Not only the ammonium chloride, but also the sodium hydroxide. Okay? Ito siguro ngayon yung big question sa isip niyo. Sir, di ba, ito yung buffer mo. Ano ginagawa ni sodium chloride? Ni sodium hydroxide. Ano nga ba ginagawa niya? So, ganito. Let's contextualize. We have ammonia as the base. And sodium hydroxide is a base. So, there will be no reaction between them. Okay? So, sodium hydroxide and ammonia, no reaction. But how about the conjugate acid, yung ammonium chloride? Will the conjugate acid have a reaction with the sodium hydroxide? Yes, kasi acid yun eh. Even though it is a conjugate acid, it is still an acid. So, ibig sabihin, there will be a reaction sa kanila. Okay? So, magbabago, bale, yung kanilang concentrations. Okay? So, yung sodium hydroxide, babaguhin niya yung concentration ng ammonium chloride. Not only ammonium chloride, no? Yung ammonia din. Okay? Siguro para mas ma-visualize yung maigi, I'll write the Henderson-Hasselbalch equation. I'll use the POH pa rin. Okay? So, I'll still use the POH. Again, very important to, no? Kasi magagamit natin to sa next topic. Now, as I said to you, the sodium hydroxide will affect the reaction, no? May effect siya sa ating chemicals concentrations, okay? Ano yung effect niya? So its effect is to change the concentration of the conjugate acid, no? So yung ammonium chloride, ma-convert niya into what? Into a base. So ibig sabihin, kung ilan yung nabago sa conjugate acid, ganun din pala karami yung mababago sa sa ammonia. Okay? So mababawasan yung conjugate acid, nadadagdagan yung base, yung ammonia. Yun yung purpose ng sodium hydroxide. Okay? So, how will we show that in our problem? So we can show that in our problem by doing this. So, yung ating conjugate acid, mababawasan yan. So, bawasan natin siya ng concentration ng NaO. And then yung base, madadagdagan siya ng concentration ng NaO. Bakit madadagdagan uli? Kasi nga, sabi natin, the conjugate acid will be converted into a base with the help of sodium hydroxide. Okay? So, si sodium hydroxide yung dahilan. Okay? So, ganun lang. So, all we need to do is to plug in everything. So, that's POH equals negative log of 1.8 times 10 raised to negative 5 plus the logarithm of this thing here. Okay? So, yung mga diluted to ha, yung mga diluted concentration. So, for the conjugate acid, so that will be 0.288. And then for the sodium hydroxide, 0.01. For the ammonia, that's 0.24 plus 0.01. So this is now the pOH. Sorry, my throat is kind of masakit. So it's 4.79, and the pH is just 14 minus pOH, and that will be 14 minus the pOH, 9.21. Okay, so what happened? Summarize ko yung nangyari para mas maging clear lalo. So ano nangyari? In the problem, we added base to our buffer system. So what will you expect? You added a base. So syempre, tataas dapat yung pH. Does it show? Yeah, no, it shows, no? Kasi, look, the original pH of our buffer system is 9.18. But when we added sodium hydroxide, the pH then increased to 9.21. So, tumaas siya onte. Okay? So, yun. Yun yung pinaka-point ko dito kanina. Okay? So, ginamit natin yung sodium hydroxide. So we can increase the amount of base and decrease the amount of conjugate acid. And then by doing that, the pH will rise. Sir, paano naman kapag hydrochloric acid yan? So if you use hydrochloric acid, dadami yung conjugate acid, mababawasan yung base. Okay? So don't worry. For now, gusto ko lang maging familiar kayo with this one. But when we do chapter 5 discussion, we will study that in depth. Mas marami tayong matututunan doon. Okay? So yun. Basta ang kailangan, when you added a base, the pH must increase. When you added an acid, the pH must decrease. Okay? Something also quite remarkable with buffers is that, di ba, you added 20 ml, and 20 ml is a lot, no? Parang shot glass na yan. Okay? But look at what happened. The pH change is still little. Okay? So, nag-increase lang siya by how much? By 0.3. 0.03. So, ganun lang kaliit yung pinagbago sa pH. No? So, that's why buffers really don't change the pH that much. Okay? So, they can tolerate uh, changes in the pH. Okay? Kahit sobrang dami mong ilagay na base dyan or acid, kaya niya mag-withstand. Okay? And yun nga, sinasabi ko, in our body, we have many buffer systems. For example, in our respiration. Okay. We call this the bore. Tama ba ako? Yung bore something. Basta may buffer yan. Kalimutan ko to. Okay, anyway. So, in this buffer system in the body, I think it's something like bore something. Okay. So, basically, what happens here is that the pH of our blood is maintained by the exchanges of the substances sa ating dugo. Okay? For example, sometimes you produce carbonic acid, which is acidic, and sometimes you produce bases, such as bicarbonate, which is basic. So, ibig sabihin na nababalance niya yung ating pH sa body. And so, kumbaga, everything in here causes us to have maintained pH. No? So, ngayon, let's talk about the intake of, let's say, intake of air. Kapag tayo lumalanghap ng air, what happens? Our blood seems to be less acidic. Okay? So, nagiging less acidic siya because look at what happens. No? Okay, if we take in air, what happens is that yung bicarbonate in the blood, pumapasok siya ng red blood cell pala. Okay? Ganun pala. So, ibig sabihin, mababawasan yung bicarbonate, which is kind of basic sa ating blood, sa plasma. So, magiging less acidic siya. So, tataas yung pH niya. However, if we increase the CO2 in our system, let's say, hindi tayo huminga, ano mangyayari? The bicarbonate will get released sa blood, no? Okay? And when it gets released sa blood, sorry, I think hmm, am I doing it correct? Anyway, kapag hindi tayo humihinga, our blood becomes acidic, no? Kasi there will be formation of carbonic acid. Okay? Pero when we release our carbon dioxide, it doesn't become acidic, no? Medyo tumataas yung pH niya. Okay? So, yan. Sometimes there are cases wherein uh, nagkakaroon ka ng tinatawag na acidosis, no? Okay? Ibig sabihin nun, yung pH ng blood mo is either super baba, no? That it could actually cause harm to your body. Okay? So yun, it just has something to do with the respiration process. No? Ibig sabihin, kung kailangan huminga. Okay? Because if hindi, then your pH of the blood will really change. Okay? So anyway, you will learn more of that in your biochemistry. Okay? It's been a while since I reviewed my biochem. Okay? But yeah, nasa Bohr cycle something yan. Anyway, so this will be the end of the buffer discussion. So there will be a next discussion, which is solubility equilibria. So go back to the next video, which is down in your canvas, okay? And we will discuss solubility equilibria. Okay, so I'll see you there.